x over x plus 2 added to 2 over x minus 2. Let's complete this addition of these two rational functions. So first we check the denominators. The denominators are different. This means that we are going to be doing cross multiplication as we learned, right? So first the denominators, right? I'll be focusing on the numerator for now, right? I'll be simplifying the numerator. We know the denominator, they will multiply each other. So I'll multiply the numerator of this by the denominator of the other fraction, right? And the sign is plus, so plus the denominator of the other to multiply the numerator of the second one to multiply the denominator of the first one, x plus 2. So here I'm just focusing on the numerator, so I will simplify the numerator and see. So I have x times this, that will be like x squared minus 2x plus 2 times this, that is 2x plus 2 times 2, that's 4. So we have s squared minus 2s plus 2s. This one will cancel it. That will be 0 plus 4 plus 4. Right? This is what we have for the numerator. So at the end of the day, we now put the denominator. So the addition now becomes s squared plus 4 all over the denominator is what? X plus 2 to multiply x minus 2. So if you are not careful, you might be confused. This is not, the top here is s squared plus 4. It is not s squared minus 4. S squared minus 4 is the difference of two squares. But this one is addition of two squares. So we don't have that simplification for two squares, right? So what we'll do is that that's the final answer. You can't do any simplification after you have done the operation. So this is the final answer for this addition, right? This is the final answer for this addition. So we are good. Let's solve another one. So first we check the denominator. So x minus 2 and s squared minus 2 minus 1 at the bottom here, s squared minus 1 at the bottom here. So they have the same denominator. If they have the same denominator, what you do is that we just proceed. You don't do any cross multiplication. You just copy one of them as the denominator, s squared minus only one of them. Then you proceed to do the direct s minus 3 minus, over here it is only 2x, so we are going to just put 2x here. So if you simplify this, x minus 2x, that will give you negative x minus 3, right? Negative x minus 3, that's the constant, all over s squared minus 1. So this is the final answer. But if you want to do something like simplification, you have x negative x plus 3 all over, you can factorize this, right? This is a difference of two squares, so it can also be x plus 1 to multiply x minus 1, right? But this one alone is correct, but this one I'm trying to see if I can do simplification, and nothing simplify when I factorize both the top and the denominator and the bottom. So this is fine, or you can even stop here, it's also fine. So that's subtraction. Here we have multiplication of rational functions, right? So for multiplication, what we said is that you multiply the numerators and multiply the denominators together. So numerators here is going to be s squared minus 9 to multiply this one. There's no cross multiplication, right? When you are doing actual multiplication of rational functions, s squared minus x minus 6 to multiply x minus 3. So this is what we have, right? So what you do is that we are going to continue to see if you can factorize some stuff to see. So this is a difference of two squares. So we can also have s minus 3 to multiply x plus 3. This is just this one, difference of two squared. It is already multiplying x minus 2. So we keep that. Now if you factorize this one, if you factorize s squared minus s minus 6, you are going to have something like this. This one factorized will give you, let me delete this thing. So this one will give you x minus 3 to multiply x plus 2 here. And this one is the factorize of this, right? So then what you do is that you have x minus 3, already x minus 3 multiplying this one. So now you can see there are some factors common, right? So there's s minus 3 at the top and there's s minus 3 at the bottom. right? So that one cancels out. Is there any other thing to cancel? This s minus 2, this s plus 2, they cannot cancel. This s plus 3, this s minus 3, they cannot cancel. So the final answer is just this one. It's just this one. So we can say our final answer is plus 3 to multiply x minus 2 at the numerator divided by x plus 2 to multiply x minus 3. This is the final answer for this multiplication. Okay, let's solve this for a division. For a division, first we do sign change, right? Right, we do sign change. So x squared minus 4 all over x squared plus 3x plus 2. This is what we have for the first term here. We keep it like that. Then we change the sign to multiplication. When we do change the sign, the other one, we have to swap the numerator with the denominator first. Then we have this now. Now we have multiplication. So if it is multiplication, we said you multiply the numerators together, x squared minus 4 in one bracket multiplying another bracket x minus 2, this one, and then those are the denominators also will multiply themselves, plus 2 multiplying s plus 2 here, right? So first, now we try to factorize and simplify to see if there are things. This is a difference of two squares, so we can have x minus 2 to multiply s plus 2, and then this one is already here, s minus 2, right? Now let's try this one. Can we factorize this? So if you factorize this, we are going to have x plus 1 to multiply x plus 2. This is what we are going to have, and then there's already s plus 2 multiplying here. So let's see if something can be simplified. So s plus 2, there's one s plus 2 here, and this s plus 2 can go away. There's s minus 2, s minus 2, but there's no s minus 2 at the bottom. So at the end of the day, our final answer becomes something like x minus 2 is s minus 2 times s minus 2. So I can put them together, s minus 2 squared all over the denominator is x plus 1 multiplying s plus 2. So this is the final answer for this division. Yeah, these are the some of the examples that we solve. So you do and you simplify. See you in the next session.